Hello, my name is Brandon Belanti, and I'm going to demonstrate a database that I've designed and built over the past couple months. This is a database that is meant to store data about composers and musical works. As you can see from the screen, it's part of a project that I'm calling Pythagoras. The goal of that project is to be able to do some data analysis on music scores. So the scores are in XML format called music XML, and I've written scripts to parse that music score and then to output the analysis as HTML files. So I'm looking for certain patterns in the score that are used repeatedly. Those patterns are logged into this database so that when somebody eventually searches for a composer or a work of music, they can see any related composers or works of music based on those patterns. Um, Most of the data that I've entered so far has been manually entered, but in the future, the goal is to be able to retrieve a score, parse it, and then log the analysis to the database and thus the website as an automated process to make things go quicker and smoother. The name, as a side note, just comes from the Greek thinker, Pythagoras. He had a heavy influence on a lot of different fields, including philosophy and mathematics and music. So he was specifically interested in patterns and proportions. So the name Pythagoras seemed like a good fit for this kind of undertaking. Again, the goal is that somebody can use this interface here to see some visualizations about composers and their works. It would be a resource for musicians or music educators. Um, the the really cool thing would be to find some new relationships based off of patterns or compositional techniques and using machine learning to do that, but I haven't gotten quite that far yet. This is kind of version one or phase one of a much bigger project that will continue on through the next year. So some business rules for this database. There is no way for a user to enter data through the database. They can only recall data out of the database. That is to kind of keep the data integrity and make sure that the files and the data that's getting put in is kind of kept under control. Obviously, some date rules for the database. The composer's death date has to be after the birthday of the composer. The date a work was started must be before they've died as well. Um, the date a work was premiered or published could be after the composer's death date. That happens a fair bit, especially for the premiered date. Um, and then another rule that I'd just like to highlight that was actually changed. Originally, I said if a piece had multiple time signatures or key signatures, I would only take the first one. But instead, I found that was not thorough enough. I couldn't tie together the pieces that I would like to tie together, so I changed that. I had to create a lot more bridge tables and queries to accomplish that, but I think it's worth it in the end. So I'll take a really quick look at the diagrams that I've made for this database. They're under this About page here. This is the conceptual model of the database. These these light colored ovals are not actually attributes. They just represent kind of categories for thinking through this model. But we have a work. Everything is kind of centered around the work. So the work has a composer, and the composer and work are both associated with an era. And then a work has things like key signature, time signature, tempo, instrumentation, and then patterns. Like we said, that's specifically what we're interested for future analysis. That's the part that's the least built out right now because I haven't actually been able to parse the files. I've got a couple example files that I've gone through, but in terms of this large scale analysis, I have not been able to do that yet. And then all of these are attributes related to those, which then become the fields in the database. The logical implementation of that looks like this. I won't spend a lot of time on this slide. There's a lot going on here. The one thing that I wanted to point out is the ordinality and cardinality, which shows how the tables are related and their degree of relation. So for instance, this composer table and this era table are related through a composer era bridge table. And then these symbols signify that the composer must be related to at least one era. It can be related to multiple eras, but they must be related to at least one. But there could be eras that aren't associated with a composer. So these zeros here represent the era could exist without a composer, but a composer must have an era. On the flip side, a pattern must be associated with a work, but a work does not need to have a pattern. So that's kind of the cardinality and ordinality of this diagram. Going back to the home page here, actually we'll take a quick look over at some of the SQL commands behind this. So I've created several tables here: composer, era. Composer era is a bridge table there. A work table, there's a lot of attributes for work with a couple of different foreign keys and primary keys. Um, and then a lot of bridge tables. So work key is a bridge between work and key, obviously. Same with work time and time, work tempo and tempo, work instruments and instrument, and pattern table here. Ultimately, the pattern data, I'll highlight this, will be stored as JSON. So the pattern data field in the pattern table is a JSON data type. And a pattern can reference another pattern. So this is a self-referencing foreign key that also happens in the key signature table. You can have a relative key or an enharmonic key that are both related back to the primary key of key ID. So once these tables are created, I've used some insert statements here. These are statements to insert the composer. There's a lot of data here, even more data here with the works, lots of different fields, and then some of the key signatures here. The one thing that I wanted to highlight with all of this data is that I've gathered a lot of it from IMSLP, which is the International Music Score Library project. I didn't type in necessarily all this data. I copied and pasted a lot of it and then formatted it with a bunch of Python scripts and cleaned it up. And where possible, I've included a link back to Wikipedia or to IMSLP. So I'm trying to contextualize this data as much as possible. After I created the table, inserted some of the values, since there are so many bridge tables, I've created a couple views here, and most of my queries are off of the views. So I have composer view with some of the composer information, work view with some of the work information, and these are all the tables that that's pulling from, but it allows me to query a lot faster in the interface. I've used concat. This is with a separator, so it concatenates these fields, and then if there's any null values, it just avoids them, so I don't get a null return for the whole thing. Then the other thing is group concat. So instead of getting 2 returns for each composer if they have multiple eras, I get 1 row back with those eras concatenated as CV era field here. Yeah, I don't think there's much more interesting in there. There's just a lot of different scripts. So I want to make sure I get to the actual database. So this is the home page. I went with a very simple design, tried to be simple with it. You have a menu up here, search, about, and help. So there's only one search box on this page, and it's meant to just kind of really guide the user to make it really clear what they're supposed to do when they get onto the website. So you can enter a composer name here. I'm going to enter Bach, and it will return all of the different Bachs in the database. You can see there are a lot. This is what I was talking about with the eras. Instead of multiple rows for Johann Nicholas Bach here, instead of a row for Baroque, a row for Galant, and a row for Classical, I get them all returned in the same row here. The composers are hyperlinked here. So what I've done is when it returned the search, I took all the composer IDs and then added them to a link here. You can see the link, it's very small in the bottom left-hand corner of my screen. But when I click on a composer, it actually will rerun the search, but limit it to that composer ID. So if I click on any one of these composers, it'll bring that search back up, but limit it to their ID so I can see their ID. And then it also searches the works. And for Johann Christoph Bach, I don't have any works in here. And you'll see there's a lot of works missing, but that will get filled out as the project kind of goes along. Let me go back here. For Johann Sebastian Bach, I have a few works in here. So the PHP to make this possible is right here. When I get the composer, I take the composer ID here, CV ID, and append it to this search string. So I have my search file and then comp equals, so whatever the composer ID is. And then when this page reloads up at the top, I can take that URL and split it up So I take this URL, whatever the composer number is, split it up so I have just the last part of the string, and then split it up so I can see the composer and then the work numbers, and then actually take that composer ID out. That becomes composer ID, which I can then use in another query. Um, so for Bach, we have this returned for his name, his eras, born and death date, and then the nationality. We can open the Wikipedia page. I'll do that in a new tab to not lose my spot, but it'll direct to his Wikipedia page for more exploration there. The search page here is essentially a more fully built out version of that first page. So you can search by year, so composers born after 1800, or by nationality, so composers who are Czech, and it will return all of the Czech composers in the database, or composers who are associated with the Romantic era. Currently, I can't separate or I can't search for multiple eras, but I will do that in the future. It'll just be a simple split it on a comma and then be able to search multiple eras. Um, then you can search for works. There's a lot of fields here. You can search the title, the identifier, composer, composed after or before a certain year, again, the era or a time signature or key signature. This will match any kind of partial. Oops, I did not spell that right. It'll match any kind of partial matches. So if I look for Allegro, I'll also return Allegro vivace, Allegro feroce, brio, molto, scherzando, all of these different results. Same thing for instruments. If I look for, oops, sorry. If I look for works that use a symbol, um, here I have some of the Slavonic dances from Dvorak that use symbols, and also one of his symphonies. Um, The search uses a lot of where-like syntax in the SQL queries. That allows me to get a lot of similarities and not necessarily match on the exact search. So I've done this kind of dynamic search. I just gave it an always true statement. Then I can append on different queries based on what the user enters. So here's a like. So the name, like whatever this name is. And then if you enter a name that has a space in it, that's is just going to get replaced by a percentage sign, which is kind of the syntax for this like statement. So it'll search anything that matches near what the user has entered. Um, let's go back to this Bach page real quick. So I can search Bach again through here. And then again, I do this, I click his name, and it has appended that composer ID and then also recursively searched for any works that are associated with that composer ID. So I can see all the works from Bach that are in this database. I can also search, if I search for Dvorak, I can see any works that are associated with Dvorak in the database. This database is very heavily focused on European Romantic composers, only because I decided to start with Dvorak for the analysis. And so many of his contemporary composers would have been Romantic era European composers. So that is a limitation of the database right now that will hopefully be built out a lot more in the future. And then just a quick note on what the analysis actually looks like. So if I look for Bach, um, I can look here at Brandenburg Concerto number 1, and this is just information that's generated by my Python scripts. It parses a music XML file and gives me information like the key signature, the time signature, the number of measures, the instrumentation used. Currently, this is not lined up with the database exactly, which is going to change in the future, but I can see some really basic analysis about the pitches that are used, the notes that are used, all this kind of stuff. So in the future, things like these pitches and durations will all be used to tie together different pieces in the database. But for right now, it's more just straight search functionality in the database. That is a really quick overview of what I've done. A lot of the fields here could be either drop-down menus or radio button options, but I've left them as text fields for more flexibility right now. This search interface will be a little bit more designed and polished up in the future. And then the other big feature that I want to add is as you're searching for a composer here to autocomplete the composer's name. I spent a long time working on autocomplete and couldn't quite get it. So that'll be in the future with a lot of other works. But that's phase one of the project, and I'm excited about the database. Thanks for listening.